All right, great. So let's get started. A company's weekly revenue in dollars is given by R of X equals 2000X minus 2X squared, where X is the number of items produced during the week. We want to find for what X is R of X strictly greater than 0. So we're just taking our R of X, setting it strictly greater than 0, and solving using our little sign chart. Okay, we want to find the zeros, and we know that the way that we find the zeros is by factoring it. I guess since this is a quadratic, you could use quadratic formula if you really wanted to, but I'm going to factor it. I got a GCF of 2x that I can take out, leaving us with 1000 minus x. And then we'll set each one of our factors containing a variable equal to 0 and solve to find our zeros. We get x equals 0 and x equals 1000. I'm going to take my number line and I'm going to break it up at 0 and 1000. What did x represent for the context of this application?
Items produced a week.
The numbers of items produced. So we've got these 3 intervals. Would it make sense, excuse me, to choose test values in this interval over here where x is less than 0? It does not, right? We can't produce a negative number of items. So although it breaks up our number line into these 3 regions, we're not even going to use this over here because that doesn't make sense for the context of our application. So we're just checking the 2 intervals, the one between 0 and 1000 and then beyond 1000. Let's choose a number in between 0 and 1000. 5 works just fine. And we want to plug it into our polynomial and determine whether we get a positive or a negative number. I'm going to opt to plug it into the factored form. This first factor of 2x, that's going to give me a positive. And then our next factor, 1000 minus 5, that's going to give us another positive. So when I multiply those 2 positives together, I get a positive. I want to check a number larger than 1000. I'm going to choose 2000. Oh, plugging it into my first factor, 2 times 2000 is going to be positive. And then 1000 minus 2000, that's going to be negative. So positive times a negative, all the numbers in this interval are going to be negative. Now that we've created our sign chart, we want to select the intervals that we're interested in. Since our inequality is greater than 0, that means we're looking for the positive intervals. So that's just going to be this one. And it is a strict inequality, so that means that we are not going to be including our endpoints. Hey, Naomi, can you mute your mic, please, dear? Oh, not including our endpoints. We're going to get 0 to 1000. Questions, anybody? All right, well, that is polynomial inequalities. We're going to move on to rational inequalities. They're super, super similar. But we know anytime we're dealing with a variable in the denominator, we have that added concern about the denominator being equal to 0. So it's really similar, but we got a couple of little things we got to watch out for. So the first thing we want to do is write the inequality so that 0 is on one side and there is a single rational expression on the other side. So that means that if you're given a problem that looks like this, you're going to have to subtract those two rational expressions first. Or you might have one that looks like this. You're going to have to set it equal to 0 and then subtract those rational expressions before you do anything else. Like, that is step number 1. Now, I will tell you on the exam, I made sure that all of them are already a single rational expression on one side, because especially since you're not getting partial credit, I don't want you to lose all the points because you added incorrectly rather than not understanding the new stuff. But heads up on that. Okay, so next we want to identify the numbers that make the numerator equal to 0 and the denominator equal to 0. So in my brain, I think zeros of the numerator, zeros of the denominator, but that's not mathematically correct to say, because zeros, when you let y be equal to 0 and solve for x. But in my mind, that's what I think of, especially because I'm trying to tie it to polynomial inequalities. So, all right, zeros in the numerator, zeros in the denominator. Then we're going to make our sign chart just like we did before. We're going to draw our number line. We're going to graph the zeros on the number line. Those numbers are going to divide the number line into intervals. Then we're going to choose test points within each of those intervals, just like we did before, and determine whether we get a positive or a negative number. The endpoints get considered separately, right? We refer to our inequality symbol to determine whether or not we're including those endpoints. But here's where the big difference is. You must exclude zeros from the denominator regardless of the inequality symbol. The whole big important rule in math about not dividing by 0 trumps an inequality symbol. It's a bigger rule. So you must exclude zeros from the denominator no matter what. And then we're going to write our solution in interval notation. So it's really similar to the same thing. We just got to watch the zeros from the denominator, and you got to watch in the very beginning that you might have to add or subtract rational expressions. So let's solve this rational inequality. We'll write our answer in interval notation. I like to get it factored right away, especially because when we get to the sign chart, I like to plug it into each factor. So I would factor this right out of the gates. Numerator doesn't factor, but the denominator factors into x plus 5 and x plus 5. And now we want to identify zeros from the numerator and zeros from the denominator. The factored form is also so helpful in actually getting these zeros. All right, so what are the zeros from the numerator going to be?
Three.
Great. And then our denominator?
-5.
All right, notice we get that 0 and -5 twice. There's no reason to list it twice. So we just got these two zeros, one from the numerator, one from the denominator. I'm ready to make my sign chart, breaking it up at -5 and 3. Now, what I like to do just to remind myself that I cannot include a 0 from the denominator no matter what, because I might forget after I do all that test point stuff. So what I like to do right now is I like to put a big X on any 0 that came from the denominator. That just reminds me that I won't be able to include that in my answer no matter what my inequality symbol says. And now we're ready for our test points. So choosing a number less than -5. I'll plug that in. Now, we usually talk about our even-odd rule for positives and negatives just in multiplication, but that whole even-odd rule is true for division as well. It's just rarely do we divide 7 numbers, but it works here as well. So I'm just looking for how many positives and how many negatives I have. If I plug in a -10, this first factor is going to be negative. In the bottom, -10 plus 5, also negative, also negative. So 3 negatives, when I multiply and divide them together, leaves me with a negative. Next, we want to plug in a number between -5 and 3. 0 is always my choice when I can. Plugging 0 in, this first factor on the top is going to be negative, and then both of them on the bottom are positive. So I have 1 negative and 2 positives. That's going to leave me with a negative. And then last but not least, we need to choose something larger than 3. 5 will work fine. Plugging 5 in, I'm going to get a positive on top and 2 positives on bottom. 3 positives result in a positive. Questions on the sign chart at all? I purposefully do an example like this to show you that it does not always alternate positive and negative. When we're in class, inevitably somebody every time says, oh, well, you just get the first one and then alternate positive and negative. Nope, that does not always happen. We see that that's not happening right here. So we can't take that shortcut. Now that we have our sign chart filled in, we're ready to select which intervals are our answer. We're strictly less than 0, so that means we're looking for the negative intervals. And then we need to write it in interval notation. It's a strict inequality, so that means that we are not including our endpoints. What is our solution set going to be in interval notation?
Parentheses, -10, -5, parentheses, union sign, parentheses, -5, 3, parentheses.
Why'd you have to stop at -5? It looks like my shading just goes all the way to 3.
Because you always have to exclude the 0 from the denominator.
Mm-hmm. And you made a mistake that I make all the time. Look at what you wrote.
That's supposed to be negative infinity.
Yeah, it is. You chose the test point. I do that all the time. That's why I write the test point up and in a different color, because I make that same mistake all the time. So negative infinity. Don't choose your test point when you're writing your final answer. All right, but everybody catch that? We have to skip -5 no matter what. So even though it looks like my shading is like, continuous there, clear through, it's not. We got to stop at 5. Even if this did not, -5 rather, Even if this did not come from the denominator, we would have had to skip -5 because it's a strict inequality. Okay, great. Let's try a couple more. So it's not really any harder. It's really, I feel like it's the same thing. We just got to watch out for the zeros from the denominator. Okay, I'm going to start by factoring. Now we are in factored form, we want to identify zeros from the numerator and zeros from the denominator. What are our zeros from the numerator?
Two-thirds and 2.
Careful there, not 2/3.
Oh,
3
3
halves.
halves. Sorry.
We do that in our head and then our mind plays tricks on us. And then put our zeros from the denominator. 4 and -1. And we're ready to break up our number line. And I'm going to put big red X's on the zeros from the denominator to remind myself that those can't be included no matter what. And we're ready for some test points. Something less than -1, choose -5. Plugging it into our first factor, what do we got? -10 minus 3, so that's negative. This one's negative. -5 minus 4 is negative. -5 plus 1 is negative. 4 negatives leaves us with a positive. We want to choose something between -1 and 3 halves. I always like to choose 0 when I can. Plugging in 0, get a negative, a negative, a negative, and a positive. 3 negatives and a positive give us a negative. So this next interval, now we're going from 1.5 to 2. We're kind of stuck with a decimal. So 1.75 or whatever you want to choose. Plugging that in, 1.75 times 2 is 3.5. 3.5 minus 3, this is going to be positive. 1.75 minus 2, that's negative. Next one's negative. Last one's positive. So we've got 2 positives and 2 negatives. That's going to leave us with a positive. Choosing something between 2 and 4, let's choose 3. Plugging in 3, that'll be 6 minus 3, positive. Here we're positive, negative, and positives. So 3 positives and 1 negative is going to leave us with a negative. And then last but not least, we're choosing a number larger than 4. I'm going to choose 10. Plugging in 10, that's going to be 20 minus 3 is positive. 10 minus 2 is positive. All right, 4 positive, so that rational function is going to be positive. Any questions on filling in the sign chart? We turn our attention to our inequality symbol. We want to be greater than or equal to 0, so that means we're looking for our positive intervals. It's or equal to, so we are including our endpoints, except if the end came from the denominator. We know we need to exclude all those zeros. Somebody want to give it a shot? Give us the interval notation representing our solution.
Negative infinity to -1, and then union,
What are you using at -1, a parenthesis or a bracket?
parenthesis,
Okay.
and then union 3/2 to 2,
What are you using there?
brackets,
Great.
and then union parenthesis 4 to positive infinity.
Looks perfect to me. So our inequality symbol was or equal to, so we want to use the square brackets for all of the endpoints, except if those endpoints came from the denominator, that our rule about not having a 0 in the denominator trumps the inequality symbol, so we need to exclude those. That looks great. Questions, anybody? Oh man, that's it. All right, moving on to variation. I think this is the easiest section in the book, in the course, personally. All right, so we have 2 different kinds of variation that we're going to talk about, direct and inverse variation. Oh, when one quantity is a constant multiple of another quantity, we say the quantities are directly proportional to one another. We're going to let x and y represent 2 quantities, then the following statements are equivalent. Y varies directly with x, y is directly proportional to x, and y equals kx, where k is a non-zero constant. Oh, basically, these words are the same. So these are the kinds of words that we're going to see in a problem. It's going to tell us, this variable varies directly with that variable, or this variable is directly proportional to that variable. Those are the words that we're going to see. As a result of those words, this is the equation we are going to write. With all these variation problems, k is always going to be present. K is our constant of variation. K is always located in the numerator. I know right now we don't have a fraction, but with some of the other variation, we're going to end up with fractions. So k is always there. It's always in the numerator. When I think of, variation, if I hear the word direct, direct variation, right away, I think of multiplying k by something. And notice with both sets of word directs there, whether it's varies directly or directly proportional. I'm sorry, does somebody have a question? All right, you'll notice that the variable that occurs before the words varies directly or directly proportional is the standalone variable. And then the variable that comes after our varies directly or directly proportional, that's what we're multiplying k by. So it's the first variable equals k times whatever the second variable is. Now, it is possible that we could have direct variation with powers. So it might say y varies directly with the cube of x, or x to the fifth. So everything's exactly the same. It's just that when you get to this part, you're going to have an exponent on your variable. That's it. All right, let's practice going from the words to the equation. S varies directly with P. So the first variable is going to be the first one in our equation. Then we see varies directly. So that tells me that I'm going to be multiplying k by something. That thing is whatever the variable at the end of the sentence is. So S varies directly with P. So we're going to have S equals k times T. Why don't you guys try the next one? A varies directly with x squared. What'd you get for an equation?
So I got A equals K times X squared.
Perfect. Anybody get anything different? You want to talk about it? All right, that's direct variation. Next up, we have inverse variation. So again, we're going to let x and y represent two quantities, and then the following statements are equivalent. These first two statements are the words that we're going to see in the problem, and then the third, just like before, is the equation that we're going to write. So y varies inversely with x, or y is inversely proportional to x. We're going to end up writing the equation y equals k divided by x. So notice our constant of variation k is still there. It's in the numerator. But anytime I hear the word inverse when we're talking about variation, I always think that I am dividing k by something. And that something is whatever our second variable is. Just like with the direct variation, we can have inverse variation with powers on it. So you're just, throwing an exponent on that second variable based depending on what they say it is. All right, let's write an equation that describes L varies inversely with M. The first variable is first, all by itself. Varies inversely tells me that I'm going to be dividing k by something. So I better write k and then divide it by something. And what I'm dividing by is my second variable, m. We get L equals k divided by m. Why don't you guys try the next one? What do we get for our equation? Oh, go ahead.
P equals K over R squared.
P equals K over R squared. Looks perfect. Questions, anybody? It's going to build a little bit in this section, but this is like step number 1 for all of them. So we got two other kinds of variations, but basically they're just, building off the direct and the inverse variation. So the first one's called joint variation. This happens when one quantity is proportional to the product of two or more other quantities. So basically, you're going to multiply by more than one variable, k times a couple things. So joint variation just means like repeated direct variation, k times a couple things. And then combined variation is where we have direct variation and inverse variation happening at the same time. So we're going to be multiplying k by one thing and dividing it by another thing. So V varies directly with T and inversely with P. So we're going to start with V. We know K is there, so varies directly with T. So I'm going to multiply by T, varies inversely with P, so I'm going to divide by P. And of course, we don't have to have those multiplication dots in there. I'm just really trying to emphasize what we're doing. And then the next example says that S varies jointly with T and D. So we're simply going to be multiplying K by both of those variables. S equals K times T times D. Anybody questions?
Why is when you jointly multiply k with t and d, why isn't t and d in like parentheses? So
I mean,
k
I
is
guess you could if you wanted to.
Would that
Some ways
wouldn't
to write
change?
multiplication, because multiplication is associative and all that stuff, because they're all
Okay.
just variables. We can just smash them next to each other without any real indication of multiplication. But if you like the parentheses, please write the parentheses.
Okay.
Anybody else? All right, so now we're ready to build our first step. Our step number one is going to be doing exactly what we just did. We're going to write the first sentence to write the general equation. That's what we did. Then we're going to use the second sentence to find k. You'll notice in our second sentence, they give us numbers for all the variables except for k. So we're going to plug in all those numbers and solve for k. And then lastly, we're going to rewrite the general equation from step one, but we're going to put the number we figured out for k in for k. Almost like when we find the leading coefficient for a polynomial function. All right, but we need to start with the first sentence so that we can get our general equation. A is directly proportional to both B and H. What is our equation going to be?
A equals K times B times H.
You got it. Now we want to plug in all these numbers that we were given and solve for k. So Ethan, now I might put the B and the H in parentheses so I can multiply. I don't know. Maybe I would just put dots like this. So cleaning that up on the right, we're going to get 20k. And then we're going to divide. And I get k to be equal to 1/2. Oh, our final answer is to simply take this 1/2 and plug it in here for k, and then that'll be our answer. We get a to be equal to 1/2 BH. That looks familiar. So just to give you some real life application of this, one of my friends who teaches over in Lancaster, she says she always gives this example in class, so I've since stolen it. She says that her Her husband dancing out at the clubs is a combined variation. It varies directly with the amount of alcohol that he has had and inversely with the number of people that are there. So, you know, when you're thinking about how is this actually applicable, that is a very true statement. The more you drink and the less people that are there, more likely Bob's going on the dance floor. All right, so let's write another one. H varies directly with the square root of G and inversely with the square of T. So here we have this combined variation because we're directly with one thing and inversely with another thing. Somebody want to give me that equation?
$20 equals K times the square root of
No,
16.
you're ahead. You're doing step 2 already, Shane.
Oh,
Next one step, just
well,
vary.
my bad. Let's see. W equals K times G over T.
Everybody like it?
I got W equals K times the square root of G over T squared.
Yeah, you kind of just skipped over these words altogether there, Shane.
Yeah,
So
I did.
Square root of G and the square of T. When I do this in class all the time with this example, people will get like the square and the square root flip-flopped, or they don't add it in or not. So it's interesting that the same things are happening via remote instruction. And just be careful when you're reading, right? Everybody good with that equation now? All right, well then now we're ready to plug these numbers in and solve for K. 20 equals K times the square root of 16 times 0.5 squared. It's 20 equals 4K divided by half and a half is a fourth. If I take 4 and divide it by a 0.25, I get 16. So it's at 5/4. K equals 5/4. It's a nice decimal. I'd be okay with 1.25 as well. Now that we've solved for K, we're taking this number 5/4 and plugging it in for K into that general equation. We end up with W equals 5/4 times the square root of G all over T squared. Now it's not ideal to leave that 5/4 in the numerator because we have a complex fraction, but I'm not going to stress over it. I'm fine if you leave it like that. If you were going to simplify it, the numerator stays in the numerator and the denominator comes down to the denominator. Or since it's a nice decimal, I'd be fine with the decimal up top as well. All good. Questions, anybody? Okay. So now we're going to build on it one more step. So I just have a number 4 on it. We're going to do everything that we just did. Write the general equation, plug in to find K, plug K into our general equation, and then we are going to use that equation that we come up with to answer an additional question. This is definitely what you're going to see on your exam next week. I wrote the exam last night. So you're definitely going to be seeing these application problems where you're putting it all together on the test. You'll also notice that they don't say, hey, use W, T, and B. we're going to have to kind of strip down these words and select the variables for ourselves. The height that a ball bounces varies directly from the height from which it was dropped. The tennis ball is dropped from 12 inches and it bounces 8.4 inches. From what height was the tennis ball dropped if it bounces 56 inches? We're going to start with the first sentence. This is going to give us our general equation, but that's a whole lot of words happening there. I want to strip it down to just the important words that I need. This will also help me select my variables. So varies directly, that's clearly important for us. But, you know, what varies directly with what? The height that the ball bounces varies directly with the height from which it was dropped. So notice how it used the word height twice, before and after. I definitely do not want to use height as my variable because it's going to be confusing. So I'm going to pick the other words that I see there, and not words like the and a, right? So the ball bounces, the bounce varies directly from where it was dropped. So personally, I would strip this all the way down to bounces varies directly with dropped. And then I'm going to write my generic equation. So what's it going to be?
B equals K times D.
Perfect. Now we're going to use our second sentence to find K. We're just plugging the numbers in and solving for K just like before. So the ball is dropped from 12 inches and it bounces 8.4. So I'm putting 12 in for D and 8.4 in for B, and we're solving for K. Is that 0.7 maybe?
Yeah.
So now we're taking that 0.7 and we're plugging it in for K, and we get the equation B equals 0.7D. And that's where we had stopped before, but now we're just going to use this to answer the last question. From what height was the tennis ball dropped if it bounces 56? Well, so where does the 56 go in for? The B. And we're going to solve for D because it said from what height was the ball dropped. So we're solving for D. We'll divide both sides by 0.7. I think that's 80 maybe. 80, and our units, inches. So there we go. Questions, anybody? All right, let's try a couple more. A chef self-publishes a cookbook and finds that the number of books she can sell per month varies inversely with the price of the book. The chef can sell 1,500 books per month when the price is set at $8. How many books would she expect to sell per month if the price was $12? And if the chef sells 1,200 books, what was the price? Okay, let's start with our first sentence. That's going to give us the general equation. That's a long sentence, but there's a bunch of stuff in there I don't actually need. What is it that we actually need out of that long sentence? See, varies inversely. What varies inversely with what?
The number of books she can sell with the price of the book.
Okay, so notice how you said book twice. So we don't want to say book twice, just, I mean, I know that you did because that was like a normal human being sentence. But as we're like selecting variables and thinking about it for this, we don't want to use the word book because it shows up twice. So I like number and price. And all that other stuff was just fluff. So what would our general equation be?
N equals K times P.
It's inversely. So what do we do when it's inverse?
Divide.
We divide. Great. Questions on kind of sifting through all the words and getting the general equation? All right. Now we'll use the second sentence to solve for K. Says that the chef can sell 1,500 books when the price is set at 8. So 1,500 is going in for N. 8's going in for P. And we solve for K. I think that's 12,000. We get the equation N equals 12,000 over P. Could somebody double check that 12,000? I'm pretty sure, but
It's 12,000.
thank you. Now we're going to use this equation to answer the two questions posed in part A and in part B. So part A says, how many books would she expect to sell if the price was $12? We're just going to plug 12 in for the price, P. So she's going to sell 1,000 books. Part B says that if the chef sells 1,200 books, what was the price? 1,200 equals 12,000 divided by P. Multiply both sides by P, or cross multiply. And then divide by 1,200. We end up with P being equal to $10. Questions at all? All right, there is one last one. Why don't you guys try it? I'm gonna pause the video and okay, so let's start with our general equation. The illumination varies inversely with the square of the distance. So we can get the equation I equals K divided by D squared. Anybody get anything different? I mean, if you use different variables, no big deal, but are we okay on the setup? We're going to plug in the numbers from our second sentence and solve for K. So the illumination, 3.75 when our distance is 40. We multiply and we get K to be 6,000. That gives us the equation I equals 6,000 over d squared. And we want to figure out what is the illumination when the distance is 50 feet. So we're plugging in 50 for D. And we end up with 2.4. In our unit, foot candles. Which, yes, that is a real unit of measurement. And that's it on variation. Any questions, anybody? So that's actually the end of Unit 3. That's all I want to do today. It's a good stopping point. Now both of my 103s are exactly the same place, and I like it. I want to keep it that way. That's the end of the material in Unit 3. That's going to be the end of the material that is on your exam that you will be taking on Tuesday. I've already written the test in my math lab. So next Tuesday, we will not have class. All right, just like on an exam day, you spend class time taking the exam. So that's what you're going to do on Tuesday in my math lab. The exam is going to be available from 12 a.m. on Tuesday morning, so like Monday night, midnight, and then it'll be due at 11:59 on Wednesday. You'll have 2 attempts on the exam, but you'll be awarded 0 partial credit on the problems. Now I will go through and look through and see if there's like any kind of weird syntax errors where you used a capital N and they wanted a lowercase n or something like that. Like I'll go through and give credit for that, but that's about it. So since I've already written the test, I tried, because we know these problems are long, I tried to throw in some smaller, shorter, maybe easier questions in there, but I need you to know that there are problems that are, here is a 4th degree polynomial, what are all of the zeros, or rewrite it in factored form, and those problems are worth 2 or 3 times what some of the other smaller ones are. So you got to be careful not to make mistakes on those ones. The ones for the rational functions are kind of stepped out, so you'll get your partial credit for, vertical asymptote versus horizontal asymptotes. But yeah, it'll be timed either 75 or 90 minutes. I haven't finished that setting on it, but you'll be able to take it anytime in that 2-day window. You will only be able to review your results, like what you typed in and what the correct answer is, immediately after submitting. Like once you X out of that page, that's it. You're not going to be able to see where you made your mistakes. So make sure that you give yourself some time to review the test right afterwards. Does anybody have any questions about any of that?
Yeah, will you take the higher of the 2 attempts?
Yep. And the bonus quiz is still available. Hold on a second. If you don't knock it off.
And do we have a quiz? Like
Yes.
a take-home quiz?
Yep, they're all posted in D2L, and the quiz will be due to the Dropbox Monday at 11:59. Because I always want you to, do the quiz and the homework before you take the test. So both of those are going to be due Monday night. Anybody else? All right, if you don't have anything else, that's all I have today. I do have office hours, following here. So if you have any questions that you want to ask, please feel free to stick around. Otherwise, have a wonderful day, and I will see you on Thursday.